chip implanted into the human brain that directly links the human brain with the hard drive of a physical computer without a wire, without a cable. We have the biology that allows us to do, already, we have this, what those chips are allowing us to do. When we learn to access these mirror neurons in a very specific way, we have super learning. I do this personally. I mean, we can learn very, very quickly.
Do you remember a time when the thought of connecting to humanity all around the world with a single device was inconceivable? Well, that thought is now becoming a reality. In recent years, we have become aware of Elon Musk's startup Neuralink, which aims to seamlessly connect the human brain to the worldwide digital reality on the internet and instantly communicate via our thoughts. The idea of creating such a device has sparked massive interest around the world, with startup companies trying to conquer this technology. None more so than co-founder of Elon Musk's brain-computer interface startup Neuralink, Max Hodak. He seemed to see the huge potential in this technology and decided to split from Neuralink and set up a direct rival company. Max Hodak, who also served as president of Neuralink until earlier this year, also appears to have poached some of his former firm's talent for the stealth startup Science Corporation, and it has raised more than $47 million for a rival project, according to a report. New employees of Mr. Hodak's secretive new startup specialize in CRISPR gene editing technology, according to their LinkedIn profiles, suggesting the Neuralink rival could focus more on bioengineering rather than just neural hardware in order to connect the human brain to a computer. Last month, Neuralink announced a $205 million fundraiser that will be used to push forward the production of its first interface devices. The funds will be used to take Neuralink's first product to market and accelerate the research and development of future products. The sooner we do that, the sooner we can help people in need who could benefit from a Neuralink device, said CEO Elon Musk. The investment came shortly after unveiling a video showing a Neuralink-equipped monkey playing a video game. It took the 9-year-old macaque monkey only 6 weeks of practice to learn how to play the 1970s video game, Pong, after having 2 chips implanted next to its skill. The chips sent brain signals through a 1024 electrode transmission device dubbed the N1 link, allowing a computer to interpret the monkey's intentions. Neuralink plans to start human trials within the coming months, with the first commercial devices expected to benefit people with neurological disorders. Mr. Musk has said the technology could ultimately be used to cure everything from blindness to depression, while simultaneously providing a route for humans to compete with advanced forms of artificial intelligence. Also, another competitor making moves in this sector is Synchron. They have won FDA approval for an IDE for a trial of the Stentrode motor prosthesis. The company was also awarded $10 million from NIH to help fund the trial. Synchron, a brain data transfer company, is jumping to the forefront of the brain-computer interface market with 2 huge milestones. The Stentrode won the Breakthrough Device Award just 1 year ago. It is a minimally invasive brain implant designed to enable patients to wirelessly control digital devices through thought and improve functional independence. Unlike invasive BCIs, which are implanted directly into gray matter, the Stentrode passes through blood vessels. 6 patients will be evaluated in the COMMAND trial with enrollment beginning later this year. The company is evaluating Stentrode in 4 patients in the SWITCH trial, currently underway in Australia. Synchron has often been framed as a direct competitor to Elon Musk's Neuralink. Although Musk's Neuralink has raised more money than Synchron, with big investors such as Google Ventures, Peter Thiel's Founders Fund, and OpenAI CEO Sam Altman, it is falling a bit behind in the milestone category. Synchron has been greenlit to be trialed in humans, while Neuralink's technology has only been trialed on pigs and a monkey. Let's take a closer look into how the Stentrode works. A motor neuroprosthesis is implanted via the jugular vein using neurointerventional techniques. The system is designed for patients suffering from paralysis as a result of a broad range of conditions, and aims to be user-friendly and dependable for patients to use autonomously. Synchron's North Star is to achieve whole brain data transfer. Our first target is the motor cortex for treatment of paralysis, which represents a large unmet need for millions of people across the world, and market opportunity of $20 billion. So with all this recent interest in human-brain interface technology, don't be surprised to see such devices become available in the next few years, which will merge human beings into the digital world. Would you get the device implanted into your brain? What about being one of the first and going for human trials? Let me know down in the comments, guys, your thoughts.